Welcome to qnawire.
In the first part of this problem, we are going to calculate the magnitude of electric field intensity in the wall between the layers. What the magnitude of electric field is E naught. So in this case, E naught is written as E naught is equals to sigma divided by epsilon naught, where the sigma is the charge density on the layers and this epsilon naught is the permittivity of free space. So by inserting values into this equation, we can write 0.50 multiplied by 10 raised power minus 3 coulomb per m cube divided by epsilon naught, which is equals to 8.85 multiplied by 10 raised power minus 12 coulomb square per Newton meter square. So from here we can write the value for this E naught as E naught is equals to 5.65 multiplied by 10 raised power 7 volt per meter. In second part of this problem, we have to calculate the potential difference between inside and outside of the cell. But this potential difference is V naught. We can write this potential difference in terms of electric field as V naught is equals to E naught d, where this d is the displacement between the outer and inside the layer or cell. Now by inserting values into this equation, we can write this V naught is equals to 5.65 multiplied by 10 raised power 7 volt per meter into 5.0 multiplied by 10 raised power minus 9 meter. So from here we can write the value for this V naught as V naught is equals to 0.28 volt. In part C of this problem, we have to find the total electric field energy, that is capital U. We can write the total energy as capital U is equals to small u multiplied by V, where the small u is the energy density and V is the volume of the walls. Let's call it equation number 1. We can write this energy density small u as small u is equals to 1 divided by 2 epsilon naught E naught square, and we can write this volume capital V as V is equals to 4 pi r square multiplied by d, where this d is the thickness of the wall. Now let's calculate this r. We can write this V cell as V cell is equals to, this is the volume of the cell, so this will be equals to 4 divided by 3 pi r cube, where this r is the radius of this cell. So from here we can write the value equation for this r is equals to 3 V cell divided by 4 pi whole raised power 1 divided by 3. Now by inserting values into this equation, we can write this r is equals to into, here we can write 3 into 10 raised power minus 16 m cube divided by, here we can write 4 into 3.14 whole raised power 1 divided by 3. So this will give us the value for this r is 2.88 multiplied by 10 raised power minus 6 meter. Now by inserting the value of energy density and the volume of the wall into equation number 1, we can write equation number 1 as capital U is equals to 1 divided by 2 epsilon naught E naught square into, here we can write 4 pi r square d. Let's write the values into this equation. Capital U is equals to into 1 divided by 2 into 8.85 multiplied by 10 raised power minus 12 coulomb square per Newton meter square into 5.65 multiplied by 10 raised power 7 volt per meter whole square into 4 multiplied by 3.14 into R, which is equals to 2.88 multiplied by 10 raised power minus 6 meter whole square into D, which is equals to 5.0 multiplied by 10 raised power minus 9 meter. So from here we can write the value for this capital U as capital U is equals to 7.4 multiplied by 10 raised power minus 15 joule. In part D of this problem, we are going to calculate the electric field intensity and voltage when in the presence of a tissue. So this time the electric field will be E and the voltage will be V. So in the presence of the dielectric, we can write the electric field as E is equals to E naught divided by K, where this K is the dielectric constant. So this is equals to 5.65 multiplied by 10 raised power 7 volt per meter divided by 5.4. So this is equals to 1.0 multiplied by 10 raised power 7 volt per meter. Similarly, we can write V as V is equals to V naught divided by K. So this is equals to 0.28 volt divided by 5.4. So this will give us the value for this V as 0.052 volt. End of the question. Thank you.